learn how to use some of the built-in functions in Python, such as print, round, and so on. In this section, you're going to learn how to write your own functions. Now, you might ask, but why do we even need to write our own functions? Well, when you build a real program, that program is going to consist hundreds or thousands of lines of code. You shouldn't write all that code in one file like we have done so far. You should break that code into smaller, more maintainable, and potentially more reusable chunks. We refer to these chunks as functions. So let me show you how to create your own custom functions. We start with the def keyword, which is short for define. Next, we need to give our function a name. So let's call this greet. All the best practices you learned about naming your variables also apply to naming your functions. So make sure your function names are meaningful, descriptive, use lowercase letters to name your functions, and an underscore to separate multiple words. Now, after the name, we need to add parentheses. You will see why shortly. And then we'll add a colon. Now, what is going to happen? You know it. We're going to get indentation, which means the following statements will belong to this function. So here I'm going to add two statements. Hi there and welcome aboard. Both these lines belong to this function because they're indented. Now we're done with this function. We need to call it. So we remove the indentation and we add two line breaks after this function. This is what PEP 8 recommends to keep our code clean and maintainable. Now, if you forget to add two line breaks, don't worry. As soon as you save the changes, AutoPEP 8 will automatically add these line breaks for you. Let me show you. So I'm going to remove these line breaks and call this function greet with parentheses, just like how we call the built-in functions. Now save the changes. There you go. So we get two line breaks after our function. Now let's run this program. So we get these two messages on the terminal. Now here's a question for you. What is the difference between the greet and print functions? The difference is that this print function takes an input, whereas our greet function doesn't take any inputs. So let me show you how to pass inputs like first name and last name to this function. When defining a function, in between parentheses, we list our parameters. So here we add two parameters like first underline name and last underline name. Now, when calling this function, we need to supply two values for those parameters. We refer to them as arguments. So, Mosh, Hamedani. These are the arguments to the greet function. That's one of the terms that a lot of developers out there don't know. They don't know the difference between parameters and arguments. A parameter is the input that you define for your function, whereas an argument is the actual value for a given parameter. Okay, now let's change line 2. And instead of saying hi there, we can greet a person by their full name. So we can convert this to a formatted string and pass two fields here, first name as well as last name. Save the changes, run the program, and this is what we get in terminal. Now this function is more useful. We can reuse it and call it with different arguments. So let's greet John Smith as well. Run the program. So we get hi Mosh Hamedani and hi John Smith. Now note that by default, all the parameters that you define for a function are required. So here our greet function takes two parameters. If I exclude one of these arguments and save the changes, you can see we have this red underline. So Pylint is complaining and saying there is no value for argument last name. Also, if we run the program, we get this type error, greet missing one required positional argument. So let's put this back. Now later I will show you how to define optional parameters. So this is the simplified version of this greet function we created earlier. Now in programming, we have two types of functions. Functions that perform a task and functions that calculate and return a value. Here are some examples. Both the print and greet functions are examples of type 1. They're performing a task, which is printing something on the terminal. In contrast, the round function is an example of a function that calculates and returns a value. So the functions that you create fall into these two categories. Now let me show you how to rewrite this greet function, but in the second form. So instead of printing this string on the terminal, we simply return it. Let me show you. So I'm going to delete all this code, define a new function, but call it get_greeting. We add the name parameter and simply return this formatted string hi name. That's all we have to do. So we use the return statement to return a value from this function. Now we can call this function get_greeting, pass a name like Mosh. Because it returns a value, we can store that value in a separate variable like message. Now you might be curious, which form of these greeting functions is better? Well, with this first implementation, we are locked to printing something in the terminal. In the future, if we want to write that message in a file or send it in an email, we have to create another function. So we cannot reuse this greet function in other scenarios. In contrast, this second form is not tied to printing something on the terminal. It simply returns a value. Now we get this value and we can do whatever we want with it. We can print it on the terminal, or we can use the built-in open function to write this message to a file. So we can create a file like content.txt, open it for writing. This returns a file object, and then we can call file.write message. Now don't worry about these two lines. Later in the course, I'm going to talk about working with files. But what I want you to take away here is that we have this message variable and we can do whatever we want with it. We can print it on the terminal, write it to a file, send it in an email, and so on. And one more thing before we finish this lecture. So here's our greet function. And as you can see, we're simply printing a string. Now, if we call greet, give it a name, run the program, we get this message, hi Mosh. But what if we put this inside of a call to the print function? Let's see what we get. We get hi Mosh followed by none. What is this? None is the return value of the greet function. So in Python, all functions by default return the none value. None is an object that represents the absence of a value. Later in the course, you're going to learn more about none. What matters now is that all functions return none by default unless you specifically return a value. So here, if we return some string, none will no longer be returned. Now, I just want to clarify something. Earlier, I told you that we have two types of functions in programming, functions that carry out a task or functions that calculate and return a value. So back to the code we previously had. So even though this function returns none by default, it is still classified as a function that carries out a task. Let's create another function. We call it increment. We want to use this function to increment a number by a given value. So here we simply return number plus by. Now we can call this function like this, increment 2 and 1. This returns a value, so we can store it in a variable like result and then print it on the terminal. Let's run the program. We get 3, beautiful. Now we can simplify this code. We have used this result variable only in a single place, that is line 6. So we don't really need it. So on line 6, we can replace result with a call to increment function, like this. So when Python interpreter executes this code, first it will call the increment function. It will get the result and temporarily store it in a variable for us. We don't see that variable. And then it will pass that variable as an argument to the print function. Now, If we run this program, we get the exact same result. Beautiful. Now we can make this code more readable. If someone else looks at line 5, they may not know exactly what these arguments are for. We can use a keyword argument to make this code more readable. So this 1 here is the value of this by parameter. We can prefix it with the name of the parameter like this. Now we can read this code almost like plain English. Increment 2 by 1. So if you're calling a function with multiple arguments and it's not quite clear what these arguments are for, you can make your code more readable by using keyword arguments. So here, by equals 1 is a keyword argument. Earlier I told you that all the parameters that you define for a function are required by default. In this lecture, I'm going to show you how to make the by parameter optional. So let's say we don't want to explicitly pass by equals 1 every time we want to call this increment function. We want to use this function to increment a value by 1. So we remove the second argument. Now we need to give this parameter a default value. So we set it to 1. Now if we call this function and don't supply the second argument, this default value will be used. Otherwise, the value that we specify here will be used. Let me show you. So we run this program. The result is 3. But if we pass the second argument here, we'll increment 2 by 5. So we will get 7. So you can see it's pretty easy to make a parameter optional. Just be aware that all these optional parameters should come after the required parameters. In other words, I cannot add another required parameter here. Let's call that another. I cannot add that here. If I save the changes, you can see we get a red underline here. So all the optional parameters should come after the required parameters. Now, obviously, in this case, we don't need the second parameter, so let's delete it. There are times that you may want to create a function that takes a variable number of arguments. Here is an example. Let's define this function, multiply, that takes 2 parameters, x and y, and simply returns x times y. Now we can call this function like this. So far, so good. But what if you want to pass 1 or 2 more arguments here? That doesn't work because our multiply function takes only 2 parameters. To solve this problem, we need to replace these 2 parameters with a single parameter. We use a plural name here to indicate that this is a collection of arguments. And then we prefix it with an asterisk. This is the magical part. Let me show you what happens when you use an asterisk here. So temporarily, let's delete this line and simply print numbers. Let's see what we get here. So run the program. We can see all our arguments and they're packed in parentheses. What is this? Well, earlier you learned about lists. I briefly mentioned that you can use square brackets to create a list of objects like 2, 3, 4, 5. Now later in the course, we have a comprehensive section about lists. So don't worry about the details of lists and how they work. But what I want you to note here is that the only difference between this list and what we have here is in the notation. So we use square brackets to create lists and parentheses to create tuples. Some people call it tuples or tuples. So a tuple is similar to a list in that it's a collection of objects. The difference is that we cannot modify this collection. We cannot add a new object to this tuple. Once again, later in the course, we're going to have a comprehensive section about lists, tuples, and other data structures. What matters now is that these tuples, just like lists, are iterable. So we can iterate over them, which means we can use them in loops. Let me show you. So let's write for number in numbers, colon. Let's just print one number at a time. Actually, we don't need this line, so delete and run the program. So we iterate over this tuple And in each iteration, we get one number and print it on the terminal. So now with a simple change, we can calculate the product of all these numbers. All we have to do is to define a variable like total. Initially, we set it to 1. And then in each iteration, we get total and multiply it by the current number. Or we can rewrite this statement using an augmented assignment operator. So total times equal number. Line 5 and 4 are exactly identical. So I'm going to use line 5 because it's shorter and cleaner. Delete. And finally, we'll return the total. Now, one of the issues I see often in beginners code is that they don't use this indentation properly. So they put the return statement here, and then they wonder why their function doesn't work properly. If you put the return statement here, it will be part of the for loop, so it will be executed in each iteration. In this case, after the first iteration, because of this return statement, will return from this multiply function. So the total will not be calculated properly. We need to put this at the same level of indentation as other statements in this function. So here we have our for statement. We loop over all the numbers, we calculate the total, and then finally return it. So with this implementation, we can get the result and print it on the terminal. Let's run the program, and you can see the product of these numbers is 120. So in the last lecture, you learned the syntax to pass a variable number of arguments to a function. We have a variation of this syntax with double asterisk, and that's what I'm going to show you in this lecture. So for this demo, let's rename this function to save underline user and rename the argument to user. So let's imagine we're going to use this function to save information about a user. Now, in this function, let's just print this user argument. We're done with our function. Let's call it save underline user. Now, instead of passing arbitrary arguments here, we can pass arbitrary keyword arguments. Remember keyword arguments? So we have name equals value. So here we can add multiple keyword arguments like ID equals 1, name equals John, age equals 22, and so on. So we are passing 3 keyword arguments to this function. Now let's run this program. This is what we get. Look at the syntax. We have these curly braces, and in between them, we have multiple key value pairs. So key colon value, comma, here's another key value pair, and here's the last one. This object you see here is called a dictionary. It's another complex type or a data structure in Python, and I'm going to talk about that in detail later in the course. For now, all I want you to take away is that when we use double asterisk here, we can pass multiple key value pairs or multiple keyword arguments to a function, and Python will automatically package them into a dictionary. So this user object here is a dictionary. Now using the bracket notation, we can get the value of various keys in this dictionary. So we can print user, square brackets, we pass a string, and this is the name of our key, like ID. Let's run the program. We get 1, or we can access the value of name key, run the program. So name is John. So this is how dictionaries work. In programming, we have a very important concept called scope, which refers to the region of the code where a variable is defined. So in this example, we have this message variable. The scope of this variable is the greet function. It only exists inside of this function. So if we go outside of this function and try to print message, see what happens. As soon as I save the changes, we get this red underline, undefined variable message. And if we run our program, we get this name error, name message is not defined. The same rule applies to the parameters of our functions. So if we add a name parameter here and then try to print it outside of the greet function, we get the same error. So the scope of the name and message variables are the greet function, and we refer to these variables as local variables in this function. They're local in this function, which means they don't exist anywhere else. And that means we can have another function, let's say send email, with a parameter with the same name. Here we can have a message variable, but this message variable is completely different from the message variable we have in the greet function. And of course, the same rule applies to the name parameters in these functions. They are completely separate. These local variables have a short lifetime. So when we call, let's say, the greet function and pass a name, Python interpreter will allocate some memory and have the name and message variables reference those memory locations. When we finish executing the greet function, because these variables are not referenced or used anywhere else, eventually they get garbage collected, which means Python interpreter will release the memory that allocated for these variables. So these are the local variables. In contrast to local variables, we have global variables. So if we move this message variable outside of the greet function, now it's a global variable, which means it's accessible anywhere in this file. So the scope of this variable is this file. We can use it anywhere in this file, in any functions or outside of a function. Now, for this reason, global variables stay in memory for a longer period of time until they are garbage collected, and you should not use them that often. In fact, global variables are really evil. So as a best practice, create functions with parameters and local variables. Now, what if here in the greet function, we set message to, let's say, B. Now, let's delete this second function. We don't really need it for now. So we call the greet function. In this function, we assign a new value to the message variable. Now let's print this message and see what we get. What do you think we're going to get? Well, let's take a look. We get A. But didn't we change the value of message variable to B? Not really. Because by default, Python interpreter treats this message variable as a local variable in the greet function, even though it has the same name as the global variable that we have on line 1. So these two variables are separate. Now, I've seen some tutorials or even books teaching you bad practices. For example, they show you how to modify the value of this global message variable inside of a function. Let me show you how to do that. But remember, this is a bad practice and you should avoid it at all times. I will explain the reason in a second. So these tutorials or books teach you to use the global keyword here and reference the message variable. When Python interpreter sees this line, it will realize that in this function, we want to use the global message variable. So it will not define a local variable in this function. Now with this change, if we run our program, you can see we get B on the terminal because in this function, we are modifying the value of the global message variable. Why is this bad? Because it is possible that you might have multiple functions that rely on the value of this global variable. If you accidentally or deliberately change the value of this global variable in one function, this might have a side effect in other functions. Those functions may not behave properly. And this way we can create a bug in our program. So global variables have always been bad. This is not a Python thing. This is a discussion that's been going on for decades. Avoid them as much as you can. Or if there are situations that you really need to define a variable globally in a file, that's okay, but do not modify it in a function as you see here. This is a really bad practice. So that's all about local and global variables. One of the questions that often comes in programming interviews is the FizzBuzz algorithm. You might be surprised that there are a lot of developers out there with even years of experience, but they don't know how to solve this simple programming problem. That's why I decided to include this in my course. So let's see how this algorithm works, and then you can spend 10 to 15 minutes on this exercise on your own. So here we have a function, FizzBuzz, that takes an input, and depending on the input we give it, it returns different results. Here are the rules. If the input that we give it is divisible by 3, it will return the string fizz. Let me show you. So we run this program, we get fizz. If the input is divisible by 5, it will return buzz. Take a look. Here's buzz. Now the third rule. If the input is divisible by both 3 and 5, it will return fizz buzz. So let's pass 15 here. We'll get fizz buzz. For any other numbers, it will return the same input. So if I pass 7, it's not divisible by 3 or 5, it will return 7 itself. So spend 10 to 15 minutes on this exercise. You will see my solution next. All right, let's see how we can solve this problem. So we get the input and check to see if input is divisible by 3. Then we can set a variable like result to fizz. Now let me temporarily simplify these rules because I want to show you a really cool technique. So let's imagine if the input is divisible by 3, we'll return fizz. Otherwise, we'll return buzz. So else colon, we set the result to buzz, and finally we'll return this result variable. This is one way to implement these rules, but it's not the best way. There is a better and cleaner way. Let me show you. So instead of defining this result variable and then returning it, we can simply return this string here and also here, and then we can get rid of line 6. So we remove one unnecessary line of code. This was one technique. The other technique I want to show you is when you have an if statement and in your if block, you're returning a value, you don't really need an else clause. Because if this condition is evaluated to false, the control moves to the else clause, and all we are doing here is returning a different value. So this is the only possible outcome. So here we can remove this else clause and simply return buzz. So with this technique, I removed an unnecessary indentation as well. I've made our code more linear, okay? Now, let's go back to our original algorithm. So if the input is divisible by 3, we'll return fizz. Now we check to see if the input is divisible by 5, we'll return buzz. So here, we don't really need an elif, because if this condition is false, we'll get here anyway. So we can check if input is divisible by 5, we will return buzz. Once again, if this condition is false, the control moves here. Now we check to see if the input is divisible by 3 and it is also divisible by 5, then we will return fizz buzz. Now, this expression is a little bit long. I would prefer to make it more readable by putting parentheses around the first and second parts, like this. That is cleaner. Now, if this condition is also false, the control moves here. That means our number is not divisible by 3 or 5, so we should simply return the same input. Once again, we don't need an else or another if. We simply return the input. Now let's run this program and see if it's working properly or not. So we call our function with 3 and we get fizz, beautiful. Let's call it with 5. We get buzz, perfect. What if we call it with 15? We should get fizz buzz. However, we get fizz. What is going on here? The reason this happened was because when we pass 15 here, line 2 is executed. Obviously, 15 is divisible by 3, so that is why we immediately return fizz. To solve this problem, we need to move this condition, which is more specific, to the top. So I've selected these two lines using Alt and up. I move these lines up, beautiful. All right, now let's run the program one more time. So we get fizz buzz. Once again, let's test it with 3. Now we get fizz. Let's test it with 5. When writing functions, don't assume that your function is working. Make sure to test it with all different kinds of values. Let's test it with 5. We get buzz, beautiful. What if we pass 7, which is not divisible by 3 or 5? We get 7. Beautiful. Hi guys, thank you for watching this tutorial. My name is Mosh Hamadani, and I have tons of tutorials like this for you on my channel. So be sure to subscribe, and also please like and share this video. If you want to learn Python properly from scratch with depth, I have a comprehensive Python tutorial for you. The link is below this video, so click the